Hello champions, welcome to my next lecture on the complex analysis. Today I will explain you 25 plus examples related to the residue theorem. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel where you can find the playlist of the complex analysis. You can see our last lecture was on state and proof the Cauchy residue theorem, and you can watch about my these previous lectures to get the easy way to learn the complex analysis. Now, again, the same question arises for you. Can you solve all these integrations with a very simple manner? For example, you all knows how you can solve the first integrations. You can either use as the partial fractions or you can use as the substitution. But that will take at least 15 minutes to get your answers. So in order to understand this integration in an easier manner, we will use the concept of the residue to solve these integrations in a very simple manner. How you can solve the residue? We will use the Cauchy residue theorem, and the statement of the Cauchy residue theorem is how you can integrate of the fz, which is defined as 2 pi iota sum of the complete residues. Now the big question arises is how you can find the residue of the function fz. For that, I already explained you the 4 different ways how you can find the residue of the functions. So you must watch all these lectures. Once you can compute the residues, you can add them, you will get the answer of this problem. Or how you can solve these integrations? Firstly, you can find the residue of the function fz by either of these 4 lectures which are available at my YouTube channel. फाइन, आप देख सकते हो इसी में प्लेलिस्ट में अवेलेबल है, सीरियल ऑर्डर वाइज चल रहा है आपका पूरा प्लेलिस्ट. देन based on this residues you can find the integration as 2 pi iota times the sum of the residues. मैं बार बार कह रहा हूं स्टूडेंट्स, you must watch about all these lectures of the residue to understand this Cauchy residue theorem in a simple manner. So another remark is whenever you have the finite number of the poles, then you can also find the residue is residue at the finite pole plus residue at the infinity is my 0. So you can use this concept also to find the residue in order to make the calculation simple. So let's start with the numerical examples. The first example, you can see how you can integrate the functions over the curve z is equal to 1. So I can consider the f of z is 1 plus z divided by z over, fine. This is the equation of the curve. So can you draw the curve? The curve is my equation of the circle with a radius 1. Now your target is to find the residue of this function. How you can find the residue? So firstly we can find the pole. How you can find the pole? We can put the denominator as my 0. So this implies z is equal to 0 and 2. Fine. Now you can check where the z is equal to 0 lies. Z is equal to 0 lies inside the circle. Z is equal to 2 lies outside the circle. This point is lies outside the circle. Therefore, there is only one pole as the point z is equal to 0. So therefore, by the Cauchy residue theorem, we need to find the residue only at the point z is equal to 0. Clearly say z is equal to 0 is the simple pole. So once we know it's a simple pole, how you can find the residue at the simple pole? We can take the limit z approaches 0, z minus 0 of fz. I can substitute the value of the fz. You can substitute the value of the fz. This is the function of the fz. Now you can see z will be cancelled out. The expression will be 1 plus z, 2 minus z. Now you can substitute the z is equal to 0. Answer is my half. Substitute the value of the half at this point. Your final answer will be pi iota is the right answer. Second example. Again, this is the curve and the given function is my fz. So you can firstly draw the curve fz. Can you find the pole? Pole means the denominator part as a 0. Fine. This implies z is equal to 5 and z raised to power 17 is 1. What does it mean? That implies z is 1 raised to power 1 over 17. Or you can say this is the 17th. root of the unity. So you can see 17th root of the unity, or you can say this is 5. You can also say it's a 1 omega square up to omega 16. Fine. Now out of all these roots, how many are lies inside? Clearly say z is equal to 5 lies outside the circle or outside the domain. Fine. While all these roots, because the product of the root is my 1, so all these roots are lies inside the circle. Fine. So therefore your target by using the Cauchy residue theorem is find the residue at the 17th root, or you can also say that 2 pi iota residue at the value of the 1 plus residue at the value of the omega plus residue at the value of omega square plus residue at the value of the omega raised to power 16. Now, क्या आप इतने सारे रेजिड्यू निकाल सकते हो? These are the 17 values. That will take a lot of the time. Fine. That will take a lot of the time. So what is the simple way? Instead of finding all these residues, what is the simple way I can suggest to you? You can see what are the poles. These are my poles. Fine. Now we can find the concept of residue at the point infinity plus residue at the poles. Poles are my z is equal to 5 of the f plus residue at the point of 17th root of the unity of the fz. The sum of the pole is my 0. Make sure student, कहीं आप ये सोचो कि 5 तो इसका पोल ही नहीं है. Fine. बट जब भी आपको सम ऑफ द पोल रेजिड्यू निकालना है, दिस इज कंसिस्ट ऑफ ऑल दोज पोल्स वेदर इट लाइज आउटसाइड, फाइन, वेदर लाइज इनसाइड और वेदर लाइज ऑन द कर्व सी. जब भी आपको ये यूज करना है इंफिनिटी प्लस द रेस्ट ऑफ द पोल. नाउ योर टारगेट इज टू फाइंड द रेजिड्यू ऑफ द this point. So I can find the residue at infinity minus residue at the 5 points. So I can substitute this value at the point of given equations. Now how you can find the residue at infinity? देखिए कितना आसान. You can see residue at infinity lecture. इसलिए मैं बार बार कह रहा हूं ये लेक्चर सुनिए, आपको ये चारों लेक्चर सुनिए, आपको रेजिड्यू निकालने का तरीका समझ में आएगा. So how you can find that? This is limit z approaches infinity minus z into fz. I can substitute the value of the fz. Limit z approaches infinity minus z over z minus 5 z raised to power 17 minus 1. So clearly say when you substitute infinity, answer will be 0. How you can find the residue at the point 5? Clearly say z is equal to 5 is a simple pole. I can find the residue is limit z approaches 5 z minus 5 of the fz. I can substitute the value of the f. Fine. You will get the 1 over z raised to power 17 minus 1. Now you can substitute both the answers at the given point. Your final answer will be minus 2 pi iota divided by 5 raised to power 17 minus 1. Look at the third example. Calculate the residues. Find the integral using the residue theorem. First of all, this function is my fz. Can you find the pole of the function? I can find the pole is by taking denominator as a 0. This implies z is equal to 0 or sin z is 0. This implies z is equal to 0 and z is equal to n pi. Now you can see n is my integer. Fine. Now out of all these poles, how many poles are lies between 0, circle 0? Clearly say the first value 0 lies. Fine. What is the meaning of this case? N is integer, is a 0 plus minus pi, n is 2 plus minus 2 pi and so on. Plus minus pi lies outside because pi is my 3.14 which lies outside. So that means the only pole which lies corresponding to the n pi is my 0. So this implies z is equal to 0 comma 0 is the only pole which lies inside the circle. So that means this is my double pole. Therefore, by the residue theorem, your target is to find 2 pi iota times residue at the point 0. But make sure residue at the point 0 is my double pole. Fine. How you can find the residue at the double pole? We have the two different methods as I mentioned you. The first method is we can use the concept of the derivatives, or we can use the concept of the coefficients. So I will tell you both the methods in this lecture. First method is I can substitute the value of the fz. This 1 over z into sin z is my fz. I can substitute the value. It's a limit. Z approaches 0. 1 factorial is 1 dz into over z over sin z. Now can you find the derivative of this function? How you can find the derivative? I will take the u over v rule. This is my sin square z, v into u minus u into v. Fine. Now clearly say when you substitute z is equal to 0, this my 0 by 0 form. Once it's a 0 by 0 form, I can apply the L'Hopital rule. So the derivative of the sine is cos z. I can use the product rule. It's a 1 into cos z minus z into sin z. And the derivative of the denominator is 2 sin z into cos z. Fine. Now clearly say if you open them, cos z and cos z will be cancelled, and it's a minus minus plus. This will be cancelled. Then sine and sine will be cancelled. The remaining term will be z over 2 cos z, and clearly say this limit will be 0. Once you can find the residue at the point is 0, I can substitute this in the given formula. We will get the answer is 0. If you apply the second methods, that is by using the coefficient of this 1 over z, clearly say the function is my sin z, which is a part of special functions. Fine. And how you can find the residue of the special functions? You can watch about my type third. I can start with the sine series expansion. What is the sine of z? Z minus z cube over 3 factorial plus z5 over 5 factorial and so on. Because sine of z is appear in the denominator, so I can take z is my common. Whenever that special function is written in the denominator, your target is to make the first term as a 1. Then 1 minus z square over 3 factorial and so on. Therefore, what is the value of the 1 over sin z? I can take the reciprocal. It is 1 over, it's a 1 minus z square over 3 factorial minus so on. I can take it as a negative 1. Apply the binomial expansion. What is the series of the 1 minus x raised to power minus 1? It is 1 plus x square plus x cube and so on. I can substitute this value. It is 1 plus z square over 3 factorial and so on. Fine. Now you can substitute this value. So what is your fz? Fz is my 1 over z into sin z. So I can substitute the value of the 1 over z. It's a 1 over z square into the same expression. Fine. Now can you find the coefficient of 1 over z? Because the point is 0, your target is to find the coefficient of 1 over z minus 0 in fz. So can you find the coefficient of the 1 over z? So there is no coefficient. Answer is 0. Fine. So once you can see the coefficient is my 0, answer is 0 is the required answer. Look at the next one. Find the residue. Use the residue theorem. Evaluate over the rectangle. So can you draw the curve? What is the meaning of these points? It is 2 plus iota, 2 minus iota, minus of 2 plus iota, minus of 2 minus iota. This point I can written as a coordinate of x comma y. X is my real component, y is my imaginary component. Minus of 2 comma 1, minus of 2 comma minus 1. So x is equal to 2, y is equal to 1. This is the point corresponding to 2 comma 1. X is equal to 2, y is equal to minus 1. Minus of 2 plus 1 and minus of 2 minus 1. So your rectangle is this portion and your shaded portion is, this is my curve C. Now can you find the pole of the functions? Pole means, what is the meaning of the pole? you have to find all those points for which f of z goes to the infinity. That means denominator part I can substitute as a 0 because numerator can never be 0. This implies z is equal to plus 1 and minus 1 are the pole of the function. And clearly say how you can write the 1. I can written as a 1 plus iota into 0, that is 1 comma 0. 1 comma 0 lies inside the curve. This is the value of the minus 1 comma 0. Both the poles are lies inside the curve. Therefore, by the residue theorem, I can find the residues at the 1 and minus 1. How you can find the residues at the point 1? Clearly say these both are my simple pole. Fine. Once this is the simple pole, I can find the residue is limit z approaches 1, z minus 1 of fz. Similarly, corresponding to z is equal to minus 1. I can substitute the value limit z approaches 1. If you substitute the value of the fz, this is the value of the fz, z minus 1 will be cancelled out. It is cos of pi z divided by z plus 1. Now when you substitute 1, cos of pi is my minus 1 divided by 2. Similarly, for the second term, limit z approaches minus 1, cos of pi z divided by z minus 1. If you substitute minus 1, cos of minus pi is my minus 1 divided by minus of 2. The answer is plus of 2. The first answer is minus half, second is plus half. You can substitute both the answers and you will get the answer is 0 is the required integration of this curve. Look at this another one. Find the over the unit circle. You can see that this is my special function. Fine. So once it's a special functions, I can find the residues of the fz by using series expansions. Do you know what is the series expansion of the e raised to power x? 1 plus x square over 2 factorial and so on. In this case, x will be my 1 over z. I can substitute x is equal to 1 over z in the given series. Now, your target is to find this z into fz. So, I can find the fz is z into 1 over z. I can multiply this quantity by z. This value will be z plus 1 over 2 factorial into z and so on. Fine. Now you can see this has infinitely many terms of the z raised to power n. Therefore, z is equal to 0 is my isolated essential singularities. अगर आपने ये singularities वाला lecture नहीं सुना है, you can watch and learn the concept of the singularity. You can see the singularity of the complex analysis. Therefore, z is equal to 0 is the only singularities. So by using the residue theorem, 2 pi iota times residue. And residue you can find the coefficient of 1 over z. Can you find the coefficient of the 1 over z? Coefficient of the 1 over z is my half. Therefore, you can substitute the value. You will get the answer is pi iota is the correct answer. उम्मीद करता हूँ आप वीडियो को लाइक एंड कमेंट जरूर करेंगे. Look at the next one. This is a very, very important question. Many times in the examination, this question will be asked. Look at that. My curve is circle. Fine. And the value is my f of z. Start with the pole. Can you find the pole? The first case is 1, 1 is a double pole. And correspond the second term, z is equal to 2 is the simple pole. And both the poles, z is equal to 1 lies inside, z is equal to 2 lies inside. Both the poles are lies inside the region. Therefore, by the residue theorem, we can find the integration is 2 pi iota, residue at the 1, residue at the 2. So we can start with the firstly z is equal to 2. Since z is equal to 2 is my simple pole, once we know it's a simple pole, can you find the residue at the point 2 of the fz, which is defined as limit z approaches 2, z minus 2 of fz. I can substitute the value of fz, limit z approaches 2, z minus 2 will be cancelled out, z minus 1 whole square, and the numerator is sine pi z square plus cos pi z square. I can substitute the value. The numerator is sine of 4 pi plus cos of 4 pi. Denominator is 1. Sine of 4 pi is 0. Cos of 4 pi is 1 over 1. That is a 1 is the answer. Always remember student, cos of n pi is minus 1 raised to power n. Sine of n pi is 0 whenever n is my integer. Fine. And you can see sine n pi, that's a 4, 0. Cos 4 pi is minus 1 raised to power 4. Now z is equal to 1 is my double pole. Fine. So you can start with the derivatives. 1 times derivative by using this part. Limit z approaches 1. 1 factorial is 1. D over dz. I can substitute the value. Denominator is z minus 2. Numerator value is sine pi z square plus cos pi z square. How you can find that derivative? I can use the derivative rule. U over v, z minus 2 whole square, z minus 2. How you can find the derivative? Sine derivative will be cos pi into z square, and the derivative of this angle term 2 pi z. Cos derivative will be minus sine pi z square and so on. Fine. Now you can substitute the value of the z1, but you can open this bracket or you can substitute the value of the z is equal to 1. If you substitute 1, the first value will be minus 1. Cos of pi, cos pi is my minus 1. This is a minus 2 pi. Minus z will be my plus 1. And sine of pi will be 0. Divided by 1. 1 minus 2 whole square is my 1. So answer will be 2 pi. Fine. I think this will be z is equal to 1. So sine pi will be 0. This value will be my 0. But from this case, yes, from this second term, this value is my 0. This value will be my minus 1. So that's minus 1. Substitute residue at the 1 and you will get the right answer of this problem. 4 pi iota into pi plus 1. Look at the next one. Evaluate the region where C is the ellipse of the curve. So clearly say your function is e raised to power z minus pi iota. Fine. Can you find the pole of the function? So clearly say pole is my pi minus z minus pi iota is 0. That means z is equal to pi iota. Now whether this pole lies inside the circle or inside the curve, see this is my curve is my ellipse. How you can draw the ellipse? We can substitute the value in the given curve. We can substitute z is equal to pi iota in the given curve. That means pi iota minus 2 plus pi iota plus 2. And agar to ye greater than 6 I value, that means it lies outside the ellipse. If this number is less than of the 6, then it lies inside the curve or inside the ellipse. If this is my is equal to 6, then it lies on the curve, that is ellipse. Fine. Now I can substitute the value and we will see it lies outside. Why? Because as I mentioned you, we can calculate this number. What is the z is? Pi iota minus 2 plus pi iota plus 2. And we all knows how you can find the absolute value of this complex number, which is as x square plus y square. So this part will be 4 plus pi square. This is 4 plus pi square. So you can see it's a twice of 4 plus pi square. After substitute the value of the pi square and then you can solve them, you will see this value is 7.448, which is greater than 6. Therefore z is equal to pi iota lies outside the curve. Once it lies outside the curve and there is no pole inside the curve, therefore the function is analytic. And once the function is analytic, integration is my 0 by using the Cauchy integral formula. उम्मीद करता हूँ आप वीडियो को लाइक एंड कमेंट जरूर करेंगे. Okay, evaluate the curve. Again, it's a simple. We can start with the f of z. We can find the pole. It's a square, so you have the two pole z is equal to 1 and 1, and it's a minus 3 over 2. Look at that, 1 is lies inside, minus 3 by 2. If you take the absolute value, it's a 1.5. 1.5 also lies inside the region. So all these poles are lies inside the region. Therefore, by using the Cauchy residue theorem, we can find the residue at the 1 and a residue at minus 3 by 2. So firstly, I can find the residue at minus 3 by 2. Fine. Or you can start with the residue at the 1. Because it's a double pole, so I can start with the limit z approaches 1 factorial, first derivative of z minus 1 square into fz. I can substitute the value of the fz. Fine. Z minus 1 whole square will be cancelled out. Now you can start with this derivative. Can you find the derivative of the function? So it is a u over v. 2z plus 3 square is a 2z plus 3 into 12 minus 12z minus 7 into 2. Now you can substitute the value of z is equal to 1. So once z is 1 means 5. 5 into 12 is 60. 1 12 minus 7 is a 5. 5 to a 10 divided by 3 plus 2 5. 5 square is my 25. So that is my 50 divided by 25. That is 2 is the required answer. Similarly, you can find the residue at the point 3 by 2 because z is equal to minus 3 by 2 is my simple pole. So I can start with the z plus 3 by 2 of fz. I can substitute the value of the fz. Fine. Now you can substitute the value of the fz. Limit z approaches minus 3 by 2. I can take the LCM. Then this number will be my 2z plus 3 over 5. And then 2z plus 3 over 5 will be cancelled out. The remaining expression will be half 12z minus 7 over z minus 1 whole square. Fine. It's a half will be there. Now you can substitute z is equal to half minus 3 by 2. This number will be my minus 18 minus 7. Z is equal to minus 3 by 2. It's a minus 5 over 2 whole square. So that is minus 25 over 2 into 25 into 4. Answer will be minus 2 is the correct. Now substitute both the answers at the given point. 2 minus 2, the answer will be 0 is the correct answer. Look at this another one. Again you can see sine hyperbolic is the special function. Fine. So your target is to find the residue by using the coefficient of 1 over z. Firstly, let's start with the pole. Sine square, z square of sine hyperbolic. That means, fine. This is the meaning of quantity. Now remember always students, what is the sine of iota z? It will be iota times sine hyperbolic z. And what is the rule for the cos iota z? It will be cos hyperbolic z. Now you can see it's a sine hyperbolic z. So I can say this number is my 0, 0, or I can also say this is my sine of iota z is 0. This implies z is equal to 0 and 0. When the sign will be 0, sine term will be 0 when it is my n pi, where n is my integer. Fine. So that implies z is I can find the value of the z is n pi over iota. But iota can never be in the denominator, so I can rationalize them. This number will be minus n pi iota. Fine. Now, out of all these poles, how many are lies inside the curve? So clearly say your curve is my 2. Firstly 0. If I substitute 0, whether it lies, so you can see is a minus 1. Yes, it is less than 2. That means it lies inside the curve. Minus n pi iota, that means 0, 0. When n is 0, it's a 0. When n is equal to 1, it is my minus pi iota minus 2 pi iota, and or you can say it's a plus minus. Fine. So clearly say whether pi iota lies, you can see pi iota minus 1. It is 1 plus pi square. So clearly say this number is my greater than of 2. So that means pi of iota lies outside the curve. Once the pi iota lies outside the curve, 2 pi iota also lies outside the curve. The only pole which lies inside is z is equal to 0. And clearly say it has triple pole. Fine. So how you can find the residues? So the first method is you can start with because z is equal to 0 is of the triple pole. The first method is you can start with the 1 over 2 factorial, second derivative of z cube f z, but that will take a lot of the calculation. You need to find the 2 times derivative of these functions. Otherwise you can find the residue is coefficient of 1 over z minus the pole is 0 in fz. Fine. So I can start with the sine hyperbolic expansion series. We all know sine hyperbolic expansion series is 1 plus z cube plus z5 over 5 factorial and so on. बच्चों मैं इसलिए कह रहा हूं आप ये वाले लेक्चर्स जरूर सुनिए जो मैंने आपके लिए ये रेजिड्यू के ओके 4 टाइप्स आर देयर. इफ यू वॉच ऑल दिस लेक्चर्स आपके रेजिड्यू तुरंत निकलेंगे. अगेन sine hyperbolic is in the denominator. Your target is to make the first quantity to be 1. I can take z as a common and here. Now your target is to find the sine 1 over. So I can take the reciprocal. This value will be my minus 1. Fine. Now we can use the expansion series. 1 plus x raised to power minus 1. 1 minus x plus x square minus x cube and so on. Remember students, if you want to use the expansion of 1 minus x, then all the values are my positive. Plus x square plus x cube and so on. Now this is my x. You can start the series which is 1 minus of the x plus x square so on plus x square and so on. Fine. Now you can find the value of fz. तो कितना कुछ रह गया इसमें, सिर्फ एक जेड स्केयर से आपको डिवाइड करना रह गया. तो जैसे आप जेड स्केयर से डिवाइड करोगे इट विल बी माई जेड क्यूब. फाइन. एंड द रेस्ट एक्सप्रेशंस आर. नाउ फाइंड द कोफिशिएंट ऑफ द 1 ओवर जेड. कोफिशिएंट ऑफ द 1 ओवर जेड इज माइनस 1 ओवर 3 फैक्टोरियल. और आप यहां से भी देख सकते हो जेड की हाईएस्ट पावर कितनी है, नेगेटिव पावर 3. सो इट हैज ए पोल ऑफ ऑर्डर 3. नाउ हाउ यू कैन फाइंड द रेजिड्यू? दैट इज द कोफिशिएंट ऑफ 1 over z. Coefficient is my minus 1 over 3 factorial. Minus 1 over 3 factorial is minus 1 over 6. So you can substitute this. Answer is minus pi iota divided by 3 is the correct answer. Look at this next one. Evaluate. Okay. I will tell you the 2 different methods. You can see I can write the tan term is sine over cos. Fine. अगर बच्चों आपके दिमाग में एक चीज क्लिक करती हो, ये क्या लिखा हुआ है नीचे, अगर मैं f ले रहा हूं इसको और इंस्टेड ऑफ दी f ले लेते हैं, चलिए इसको ऊपर इसका डेरिवेटिव तो लिखा हुआ है. फाइन. विद द नेगेटिव साइन आप माइनस लगा लीजिए. तो जब भी f और नीचे f डैश हो, कौन सी प्रिंसिपल आपको काम आएगा? बाय यूजिंग द आर्गुमेंट प्रिंसिपल. फाइन. और ये सेम क्वेश्चन मैं ऑलरेडी इस आर्गुमेंट लेक्चर में एक्सप्लेन कर चुका हूं. 15 प्लस एग्जाम्पल्स ऑफ द आर्गुमेंट लेक्चर्स. फाइन. एक तो आप इसे आर्गुमेंट से सॉल्व कर सकते हो और एक आप इसको रेजिड्यू थ्योरम से भी. मैं दोनों मेथड इसी लेक्चर में सॉल्व करके दिखा देता हूं. फर्स्ट मेथड बाय यूजिंग द आर्गुमेंट प्रिंसिपल. फाइन. सो पहले मैं इस चीज को लिख लेता हूं. tan ऑफ जेड को आप कैसे लिख सकते हो? माइनस एफ डैश ओवर एफ. तभी तो बनेगा ना ये, बिकॉज एफ का डेरिवेटिव कोस का माइनस साइन आएगा. फाइन. Now जैसे आपने इस चीज को लिखा, then your target is to find the number of the poles, number of the zeros of the f. So can you find the number of the zeros of the f and number of the poles of the f? f क्या आपका cos z. क्या ये फंक्शन कभी इन्फिनिटी जाएगा? नो। सो पोल इज जीरो। जीरोस कैसे निकालोगे? कोस जेड को जीरो कर लेते हैं, तो जेड की वैल्यू कितनी आ गई? 2n+1 पाई ओवर 2। और आपका आंसर क्या होना चाहिए? पाई माइनस पाई बाई 2 के अंदर। तो आप n की वैल्यू फिल करते हैं, n की वैल्यू जीरो, n आपका इंटीजर है, तो n जीरो लिया आपने, पाई ओवर 2 प्लस माइनस पाई ओवर 2 प्लस माइनस 3 पाई ओवर 2 प्लस माइनस 5 पाई ओवर 2 एंड सोन। अब इसमें से कितने पोल जो है वो इस कंडीशन को सेटिस्फाइड करेंगे? पहले पाई बाई 2 ले लेते हैं। पाई बाई 2 माइनस पाई बाई 2, यस इट इज लेस देन 1, तो इसका मतलब पाई बाई 2 तो सेटिस्फाइड हो गया। माइनस पाई बाई 2 सेटिस्फाइड होगा, माइनस पाई बाई 2 फिल करेंगे तो माइनस ऑफ पाई, विल इट लेस देन 1? नो। इसका आंसर 3.14 नॉट सेटिस्फाइड। 3 पाई बाई 2 सेटिस्फाइड करके देख लेते हैं। 3 पाई बाई 2 से कितना आएगा? पाई ओवर 2, इज इट लेस देन 1? नो, बिकॉज इट्स 1.57। सो the only zeros which satisfied corresponding to plus pi over 2. So number of these zeros कितने आए आपके? Only 1. एक ही तो जीरो आया आपके पास, you can see. Fine. And number of the poles are 0. So you can substitute the value 1 minus 0. 2 pi iota से multiply कर देते हैं, because हमें tan की वैल्यू निकालनी है. So that number will be 2 pi iota. Fine. और फाइनल आंसर आप इसमें फिल कर दीजिए, बिकॉज ऑफ द नेगेटिव साइन आंसर इज -2 पाई आयोटा। सेकेंड मेथड, बाय द रेजिड्यू थ्योरम्स कैन यू फाइंड द पोल ऑफ द फंक्शंस? पोल इज माई डिनोमिनेटर पार्ट एज ए 0. दिस implies z is equal to 2n+1 pi over 2. Again we can see on this curve only value pi over 2 lies in the curve. Fine. So residue is considered as pi over 2. So can you find the value of the residue at the pi over 2? I can substitute the value of the fz. Now clearly say this number is my 0 by 0 form. Fine. Then you can use the L'Hopital rule. So how you can apply the L'Hopital rule? I can derivative them, minus sin z, first function, derivative of the second, plus z minus pi over 2 into cos z. Now you can substitute z is pi over 2. Sin pi over 2 is my 1, plus 0 minus 1. Answer is minus of 1. Substitute the answer in the given formula. You will again get the -2 pi iota. Look at this another one. Again you can see this is my special function. Fine. So we can start with the series expansions. I can multiply by z raised to power 4 on the both sides. Therefore, integration of the fz is 2 pi iota, residue of the fz. Can you find the pole? Clearly say z is equal to 0 is my pole. And because it involvement of the infinitely many terms, so z is equal to 0 is the isolated essential singularity. And how you can find the residues? At the point 0, which is defined as coefficient of 1 over z in the value of the fz. So what is the coefficient of the 1 over z? 1 over 5 factorial. I can substitute the value. What is the 5 factorial? 120. Answer is pi iota divided by 60 is the right answer. Okay, look at this another one, which is again similar to the sine hyperbolic. Fine. So you can start with the pole. Sine hyperbolic I can written iota z is my n pi, z is my minus n pi over where n belongs to the integers. Fine. Now you can start with the pole. I can write here is z is equal to minus n pi iota. Now clearly say when n is equal to 0, plus minus pi iota, plus minus 2 pi iota and so on. Z is equal to 0. Yes, it lies inside. Pi iota. Yes, because pi is my 3.14. This is 6 point which lies outside. 0 lies here. Plus of pi iota lies, plus of pi iota lies in this case. Minus of the pi iota lies. So there are the 3 poles which all are my simple. We can find the residues at the point 0, pi iota, minus pi iota, and all are my simple poles. You can calculate the residues by using definitions. It's a 0 by 0 form. I can apply the L'Hopital rule. 1 cos hyperbolic z. Cos hyperbolic 0 is 1, so 1 over 1 is 1. Similarly, we can start with the pi z is equal to pi iota. I can substitute the value of the pi z, f of z, which is z minus pi iota divided by sine. It is a 0 by 0 form. I can use the L'Hopital rule. It's a 1 over cos hyperbolic z. Again, you can substitute the value of z is equal to pi iota. So that will be 1 over cos hyperbolic pi iota. अच्छा, एक और चीज, अगर आप सोचो कि सर इसको क्यों नहीं हमने सीरीज एक्सपेंशन से कर दिया, बिकॉज जीरो के केस में तो आप कर सकते हो, लेकिन यहां जीरो नहीं है. अदरवाइज क्या करना होगा आपको, पहले हर कहीं पे जहां पे भी एक्स जेड लिखा है उसको इस फॉर्म में लिखना होगा, लाइक साइन हाइपरबोलिक जेड माइनस पाई आयोटा प्लस पाई आयोटा, अगर आप रेजिड्यू पाई आयोटा के कोरस्पॉन्डिंग निकाल रहे हो. मैंने पहले बताया आपको इन लेक्चर्स में, रेजिड्यूज एट द इन्फिनिटीज, रेजिड्यू एट द स्पेशल फंक्शन. जब भी आप कोफिशिएंट का फॉर्मूला लगाओ तो हर टर्म को पहले वन उसी की फॉर्म में बनाना है, जेड माइनस जेड नॉट की फॉर्म. फाइन. So that number is my minus 1. Similarly, you can find the residues at minus 1. You will get the answer is again minus 1. Substitute all these answers. You will get the residue is minus 2 pi iota. Okay, look at this another one. अगर कोई function f दिया हुआ है where c is a circle with the radius is my 2, तो आपको डेरिवेटिव की वैल्यू निकालनी है. ओ, ये थोड़ा हटके है क्वेश्चन, आपको डेरिवेटिव की वैल्यू निकालनी है, फंक्शन की वैल्यू नहीं निकालनी. कोई बात नहीं, सबसे पहले इसका पोल निकाल लेते हैं. फाइन. व्हाट इज द पोल? पोल इज माई z1. फाइन. z1 क्या आपका 1 माइनस आयोटा, तो 1 माइनस आयोटा कहाँ होगा, ये रेडियस 2 है, सो दैट इज अ 1,1. 1,1 is lies inside the circle, so that means the pole lies inside the circle. Fine. Then मैं इसकी वैल्यू निकाल लेता हूं by the residue theorem. Can you find the residues at the point z1? Because z is equal to z1 is a simple pole, I can start the values of the z minus z1 of f. Fine. I can substitute the value f. Z minus z1 will be cancelled. Now you can see I can substitute this value. The left hand side, what is the left hand side is f of z1. The right hand side is 2 pi iota 3 into z1 square plus 7z1 plus 1. Fine. Now your target is to find the first derivative. Firstly, find the first derivative. It's a 2 pi iota 6z1 plus 7. Now substitute the value of the z1 is 1 minus iota. So it's a 2 pi iota into 1 minus iota plus 7 is the required answer of the problem. Similarly, if somebody will ask you to find the second derivative of the 1 minus iota, this is the f of z, you can find the second derivative easily. Okay, look at this another one. Find the integral of this. Firstly, I can write the quote is cos of pi z divided by sine into z minus iota square. फाइन. ये क्वेश्चन मेरे को दिमाग में आ रहा, कभी ना कभी ये CSR नेट में भी आया था ये. फाइन. चलिए इसके पोल से स्टार्ट करते हैं. इसके कोरस्पॉन्डिंग पोल क्या आएगा, आयोटा एंड आयोटा. इसके कोरस्पॉन्डिंग पोल क्या आएगा, पाई ऑफ जेड इज एन पाई, सो दैट इज माई एन. फाइन. अब इन पोल में से कौन कौन से पोल इस सर्कल को लाई करेंगे. नाउ यू कैन सी 4x स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू 2. सबसे पहले चेक करते हैं z इज इक्वल टू आयोटा. आयोटा का मतलब क्या है, x की वैल्यू कितनी होगी 0, y की वैल्यू 1, तो क्या ये इनसाइड हुआ, यस 1 इज लेस देन 2, सो z इज इक्वल टू 0 लाइज इनसाइड द सर्कल. z इज इक्वल टू प्लस माइनस, सो इस 0 होगा, एक प्लस माइनस 1 होगा, प्लस माइनस 2 एंड सो ऑन. 0, z इज इक्वल टू 0 मीन्स x भी 0 y भी 0, यस 0 लेस देन 2, तो 0 तो सेटिस्फाइड कर जाएगा। z इज इक्वल टू प्लस माइनस 1, x की वैल्यू 1 है, y 0, तो क्या ये इसको सेटिस्फाइड करेगा? 4 is not less than 2, so that means corresponding to the plus minus n, only pole which lies is 0. Fine. So therefore by the residue theorem I can find the residue at the iota. Iota is my double pole. Fine. And 0 is my simple pole. Fine. Now you can start with the double pole factorial. You can substitute the value. Z approaches iota. First derivative of z minus iota will be cancelled out. It's a cot of pi z. Can you find the derivative of the cot pi z? Z approaches iota. It is minus pi cosecant square pi of z. Fine. I can substitute the value of the z is iota. Now we all know sine of iota z. This is my iota times sine hyperbolic z. I can write this number is minus pi iota. Because of the square, it is iota square sine hyperbolic square of the pi. Iota square is my minus 1, so this value will be cancelled out. Pi divided by sine hyperbolic square pi. You can find the residue at the point 0. I can substitute the value of the fz. Fine. Now if you substitute 0, this number is my 0 by 0 form. Fine. But for the easy calculations, you can see sine cos of 0 is my 1. In the denominator, this number is my iota square. And the rest value, which becomes the 0 by 0 form, I can write it separately. Fine. Now you can apply it's a 0 by 0 form. So this number is my minus 1. I can apply the L'Hopital rule. This number is my 1 over pi cos pi z. Now cos 0 is my 1. So minus 1 over pi is the right answer of the problem. You can substitute. Your answer will be minus 1 over pi. Okay, so let me know how many of you can solve these 8 problems. These are an exercise for you. And let me know in the comment box how many you can solve the problem. After solving, you can verify your answers. Also, you can send your answer in the comment box whether you obtain the same answers or not. जिससे मैं समझ पाऊँ कि आप रियली में इस लेक्चर को अंडरस्टैंड कर पाए. Very soon we will see the next lecture on the Schwarz lemma based on your request. अगर आप चाहते हो कि मैं Schwarz lemma अपलोड करूँ, you can tell me in the comment box. Till then, you can share this video with your friends. You can like and share the comments. And don't forget to subscribe my YouTube channel. Best of luck, students. Happy learning.